Another day, another failed audio recording. I believe my headphone mic was muted the whole time, which is the reason why I recorded like a 30-minute long video for LeetCode, and none of it had any audio. My iPad also weirdly stopped recording midway, so I didn't have any footage on like my explanation. Maybe it's a good thing that I could just come back and do it again. I'm gonna try to make this explanation short. This was a little bit of a confusing problem, but I learned a lot of new concepts doing it. The problem's 3016, minimum number of pushes to type word. Part 2, you're given a string word containing lowercase English letters. Telephone keypads have keys mapped with distinct collections of lowercase English letters, which can be used to form words by pushing them. For example, the key 2 is mapped to A, B, C. We need to push the key 1 time to type A, 2 times to type B, and 3 times to type C. It is allowed to remap the keys number 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the keys will be pushed to type the string word. Return the minimum number of pushes needed to type word after remapping the keys. And we have to note that 1 hash and 0 do not map to any letters. See, so this is an example of a mapping where the word is A, B, C, D, E, and the output is 5. Because you'd press the number 2 once, the number 3, the number 4, the number 5, and the number 6. All of them just 1 time to type out the word A, B, C, D, E. In this case, the word is X, Y, Z 4 times, and you'd have to output 12. This is an example where it gets a little more confusing. We have A, B, B, C, C, D, D, all the way to H, and then 6 I's. This would be 24 because all the keys are typed twice. I typed 6 times, and then we have an H that can't really fit anywhere where you only type the key once. So it has to be fit in the ninth key, second position, thereby increasing the count by 4, right? So what's the way we approach this problem? The way I was considering doing it is by maintaining a little dictionary called count. And I later found out that there is an object that, in fact, does this for you and makes the job way easier. It's a counter object. Basically, when you call a counter object on any string or list, it will automatically count everything in that string or list for you, which is incredible. And you can use that for a lot of different things. My idea, once I counted all the characters, because the main objective here was to find the characters that appeared the most frequent times. Like in this example that I drew out, like the A appears 10 times, and I want that to have the least cost when typing out, right? Because if it's going to appear the most number of times, I might as well have it be at the very front where I only press the key once so that you don't use up a lot of counts. And then that way, if we maintain or preserve like a decreasing order of counts, right, we could automatically assign letters from numbers 2 to 9. And after one 2 to 9 iteration is done, we go back and assign numbers in the second position of 2 to 9 again. So in this case, I go A, and then the next letter, if it's like C, I would assign C to the number 3, da 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 da. And suppose we come back and now we have H, right? So it's basically an order of decreasing count. That way we're preserving having the least cost possible. So let's go ahead and type this solution out, or in fact, just go through the typed solution. I initially started by initializing a total cost and just a cost. A cost is at 1 because it signifies the one that we're multiplying with the frequency of the letters. And that will constantly go up after we fill up every 2 to 9 slot. Our count Our count of characters are just the counter of the word, as I showed. And we have this very useful feature in counters called .most common, which automatically sorts our count in decreasing order. So if I were to go ahead and print the count here, what you will see is this. A appears once, B appears once, C, D, E, correct? And if we go to a different case, like case 3, we see a decreasing order, where I appears 6, A appears twice, and then so on. Everything else appears twice. The relevance of the most common is the most common the occurring elements appear first. If you wanted to do increasing order, then you would use the sorted command. Now, once we've done that, we just want to extract all the values because that's what's most important to us. Just the 6, just the 2s, We extract the values by listifying or converting to a list all the items and the first element of the tuple or the tuple for all the items, 6, 2, 2, 2, and so on. Finally, once the values are converted into a list, we go ahead and iterate through every element in that list. And we basically check if our I, which is our for loop counter divided by 8, is greater than the cost minus 1. We're using a double divide here because we want to cast it to type int, and the double divide automatically takes care of that. And we're comparing to cost minus 1 because we're saying every time our I covers 8 positions, that is basically 2 through 9. We have 8 different numbers that we could cover. Once that is covered, up the cost by 1 is all we're saying. And we're using the cost itself as a comparative number. And finally, we're just having a total cost to which we're adding on the cost times that value in that position. We're returning the total cost, and if we execute this, it runs perfectly as expected, and we have pretty decent runtime. Great. Thank you all for watching. Hopefully this was a useful enough video and you learned a few concepts, namely the counter object and, you know, integer division. And hopefully tomorrow I see you guys for the next daily. Thanks.